Did you know that the sun's magnetic field flips every 11 years? It's currently in the process of flipping right now, but don't worry, it's a natural phenomenon. Imagine a giant magnet flipping its poles. That's our sun, constantly changing. This flip isn't just a cosmic curiosity, it's a powerful phenomenon with real impacts on Earth. So buckle up, space fans, we're diving into the sun's magnetic flip and what it means for us. The sun isn't a solid ball of fire. Contrary to what many might think, the sun is not a massive burning sphere of gas. Instead, it is a complex and dynamic entity, constantly in flux. The surface of the sun, known as the photosphere, is a fascinating place, dotted with dark sunspots that are cooler regions caused by intense magnetic activity. It's a churning ball of plasma, a superheated state of matter. Plasma, the fourth state of matter, is composed of charged particles that move freely. This churning plasma is not just a chaotic mix. It follows intricate patterns and flows, driven by the sun's immense gravitational and magnetic forces. The temperatures in this plasma can reach millions of degrees, making it an incredibly energetic environment. This plasma is in constant motion, creating a powerful magnetic field. As the plasma moves, it generates electric currents, which in turn produce magnetic fields. These fields are not static, they are constantly shifting and evolving. The sun's magnetic field is generated by a process known as the solar dynamo, which is driven by the complex motion of the plasma within the sun. Think of it like a giant bar magnet with a north and south pole. However, unlike a simple bar magnet, the sun's magnetic field is far more intricate. The magnetic poles of the sun are not fixed. They can shift and even flip over time. This phenomenon, known as the solar cycle, occurs approximately every 11 years, leading to periods of increased solar activity. But the sun's magnetic field is far more dynamic. It is constantly changing, influenced by the turbulent motions of the plasma. These changes can lead to the formation of complex magnetic structures, such as loops and arches, which can store vast amounts of energy. When these structures become unstable, they can release this energy in the form of solar flares and coronal mass ejections. It twists and turns, creating sunspots, solar flares, and coronal mass ejections, CMEs. Sunspots are regions where the magnetic field is particularly strong, inhibiting the flow of heat from the sun's interior and causing these areas to appear darker. Solar flares are sudden bursts of energy caused by the release of magnetic energy, while coronal mass ejections are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. These phenomena can have significant effects on space weather, impacting satellite operations, communications, and even power grids on Earth. The sun's magnetic field isn't static, it's a dynamic and ever-changing force that plays a crucial role in the behavior of our solar system. This magnetic field is generated by the movement of electrically charged gases within the sun, creating a complex and powerful magnetic dynamo. The sun's magnetic field extends far beyond its surface, influencing the entire heliosphere, which is the bubble of space dominated by the solar wind and magnetic field. It goes through a regular cycle lasting about 11 years. This cycle, known as the solar cycle, is a fascinating process that has been observed and studied for centuries. The solar cycle is characterized by the waxing and waning of solar activity, which includes the number of sunspots, solar flares, and coronal mass ejections, CMEs. These changes in solar activity have significant effects on space weather, which can impact satellite operations, communication systems, and even power grids on Earth. This cycle is marked by periods of high and low activity known as solar maximum and solar minimum. During the solar maximum, the sun is bustling with activity. Sunspots, which are dark, cooler areas on the sun's surface caused by intense magnetic activity, become more numerous. These sunspots are often the sites of powerful solar flares and CMEs, which are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. During solar maximum, sunspots proliferate, and solar flares and CMEs become more frequent. Solar flares are sudden flashes of increased brightness on the sun, usually observed near its surface and in close proximity to a sunspot group. These flares can release a tremendous amount of energy, equivalent to millions of hydrogen bombs exploding simultaneously. CMEs, on the other hand, are huge bubbles of gas threaded with magnetic field lines that are ejected from the sun over the course of several hours. When these CMEs collide with Earth's magnetosphere, they can cause geomagnetic storms, which can disrupt satellite communications and navigation systems. During solar minimum, the sun is relatively calm. The number of sunspots decreases significantly, and solar flares and CMEs become less frequent. This period of reduced solar activity can last for several years, and it is during this time that the sun's magnetic field begins to reorganize itself in preparation for the next cycle. The solar minimum is a time of relative peace in the solar system, but it is also a time of anticipation, as scientists and astronomers prepare for the next surge in solar activity. And at the peak of this cycle, something remarkable happens. The sun's magnetic field flips. This phenomenon, known as the solar magnetic field reversal, occurs approximately every 11 years at the height of the solar maximum. During this reversal, the sun's magnetic north and south poles switch places. This process is a natural part of the solar cycle and is driven by the complex movements of plasma within the sun. The magnetic field flip is a dramatic event that signifies the end of one solar cycle and the beginning of another. It is a reminder of the dynamic and ever-changing nature of our closest star, the sun. Sunspots are dark, cooler regions on the sun's surface. They're caused by intense magnetic activity. These spots are like windows into the sun's magnetic field. They reveal the twisting and turning of magnetic field lines. And when these lines snap and reconnect, they release vast amounts of energy in the form of solar flares and CMEs. Solar flares are sudden bursts of energy from the sun's surface. They're like giant explosions, releasing radiation across the electromagnetic spectrum. CMEs, or coronal mass ejections, are even more powerful, launching billions of tons of plasma into space. These eruptions can have significant impacts on Earth, disrupting satellites, communications, and even power grids. Fortunately, Earth has a protective shield, its own magnetic field. This field acts like a giant bubble, deflecting most of the sun's harmful radiation. Without it, life as we know it would be impossible. But our shield isn't impenetrable. During intense solar storms, some charged particles can penetrate the atmosphere, leading to auroras and other effects. One of the most beautiful consequences of solar activity is the aurora borealis, or northern lights. These mesmerizing lights dance across the night sky, painting it with vibrant hues of green, pink, and sometimes even red and purple. The aurora borealis is most commonly seen in high-latitude regions around the Arctic, such as Norway, Sweden, Finland, and Canada. The phenomenon has fascinated humans for centuries, inspiring countless myths, legends, and scientific inquiries. Similarly, in the southern hemisphere, we have the aurora australis, or southern lights. This equally stunning display can be observed in high-latitude regions around the Antarctic, including parts of New Zealand, Australia, and Antarctica itself. The aurora australis shares many characteristics with its northern counterpart, creating a mirror image of beauty in the southern skies. These dazzling displays of light occur when charged particles from the sun, primarily electrons and protons, collide with atoms and molecules in Earth's atmosphere. This interaction is a result of solar wind, a stream of charged particles released from the sun's corona. When these particles reach Earth, they are guided by the planet's magnetic field towards the polar regions, where they interact with the atmosphere and create the stunning light shows we see. The colors of the aurora depend on the type of atom or molecule being excited and the altitude at which the collisions occur. Oxygen, for example, can produce green or red light depending on the energy of the collision and the altitude. Green is the most common color, typically seen at altitudes of around 100 kilometers. Red auroras, which are rarer, occur at higher altitudes above 200 kilometers. Green is the most common, produced by oxygen. Nitrogen, on the other hand, can produce blue or purplish-red auroras. The specific colors and patterns of the aurora can vary greatly, creating a unique and ever-changing spectacle that never ceases to amaze those lucky enough to witness it. The science behind the auroras is complex and fascinating, involving the interplay of solar activity, Earth's magnetic field, and atmospheric conditions. Understanding this phenomenon not only provides insight into the workings of our planet, but also highlights the dynamic and interconnected nature of our solar system. While auroras are beautiful, solar storms can have serious consequences. They can disrupt satellites, causing communication outages and GPS errors. They can also induce currents in power grids, leading to blackouts. In 1989, a powerful solar storm caused a major blackout in Quebec, Canada, affecting millions of people. Scientists are constantly monitoring the sun, trying to predict solar storms. They use a variety of instruments, both on the ground and in space, to track sunspots, solar flares, and CMEs. By understanding the sun's behavior, we can better prepare for and mitigate the impacts of space weather. In conclusion, the sun's magnetic flip is a fascinating phenomenon that affects not only our solar system, but also our daily lives. We hope you enjoyed this journey through the sun's magnetic marvels. As we continue to study and understand this celestial dance, we gain more insights into the powerful forces that shape our universe and protect our planet. The sun's story is far from over, and as we uncover more of its secrets, we can't help but marvel at the cosmic ballet that plays out in our skies. If you enjoyed this video, please share your thoughts in the comments below. Don't forget to support our channel by subscribing and liking this video. Thank you for watching.